Hey there guys, it's Miss Campbell here, and today we're going to learn about similar figures. So to begin though, we're going to actually start with solving proportions because similar figures are about everything being proportional. So if you remember a proportion, it's basically two fractions that are set equal to each other, two ratios that are equal. And what we are going to do is to solve it, you cross multiply and then you solve. So I'm going to multiply this diagonal here, and I'm going to multiply this diagonal there. So I have 11 times x, which is 11x, and that would be equal to 8 times 3, which is 24. Okay, and then you just divide by 11. All right, and on this one, you'll get a decimal, or if it asks you to leave it as a fraction, you just leave it as a fraction. So let's do that. Let's do 24 divided by 11. And you would get the x is 2.1818, on and on and on, right? Okay. Typically, when we have these, when we're getting decimals, we're going to ask you guys to round to the nearest tenth. Okay, so I'm going to make that note, round to the tenths. All right, and what that means is we only want one decimal place. So to get one decimal place, we actually have to look at the second one. Okay, I'll look at that 8. If it's 5 or above, as y'all know the saying, give it a shove, okay? If it's 4 or below, let it go. So 8 is definitely 5 and above, so that's going to make that 1 go up to 2. So this would round to 2.2, and that would be x. All right, next one we have, okay, is here we've got 2 parts of our ratios that have fractions in them. So we'll just cross multiply, okay, still same process. All right, I'm going to do the easier diagonal first, and it doesn't matter which one you write first, okay? So I'm just going to do 7 times x, which is 7x, okay, equals. And now my other diagonal, I'm taking 12. You're always going to take just the plain number here, 12. And then whatever you have up here with the variable in it, or it could be on the bottom, wherever it is, the one with the variable, you put that in the parentheses, so 2x minus 1. Okay, so now on this side here, we're going to have to do distributive property before we can get solving. So we have 7x is equal to, and then we have 12 times 2x, so that's 24x, and then 12 times negative 1, so that's negative 12. All right, so now we will move our x's around and our constants and stuff. So I'm going to move my small x over to my big X. So minus 7x minus 7x. Okay, 7x minus 7x, that's 0. It is okay. You can have 0. All right, and now 24x minus 7x is 17x, I'm sorry. 17x, okay, minus 12. Now we just add 12 to both sides. Okay, and so I get 12 is equal to 17x. Let me move that here. Okay, I'm gonna go on this side here. 12 is equal to 17x, so divide by 17. Okay, and we will get that x. So 12 divided by 17 is 0.0705. Okay, so I'm sorry. I apologize. 0.705. Okay, and if we're going to round that to the tenths, look at that 0. Is it going to make it go anywhere? No. So x would just be 0.7. All right, so there we go. So that's solving proportions. Okay, now we're going to talk about similar figures here. Similar figures have the same shape, but they're different sizes. Okay, and the corresponding sides are going to be proportional. and you use the sides and the angles and the names of the figures to help match the parts. Okay, so we're going to look at these two over here, and this up there means triangle SIT is similar to triangle DOG. That little squiggle means similar. So it kind of looks like the congruent symbol, but without the equal sign. So it's just the squiggle. Triangle SIT is similar to triangle DOG. And now we can use the numbers and the sides to help us match. All right, if you notice, we've got two angles here. We can figure out that third one. That will help us figure out over here too. Okay, 180, because remember all three add up to 180. Okay, take away 25 and take away 48. That would in fact give us 107. So we know, now we can see like which corners are definitely supposed to match up. The 107 is going to go with the 107. Okay, the 25 over here would go with angle D. So we know angle D is going to be 25. And the 48 here at T would match with G. Okay, you can also look at the sides. Your small is going to match with small, medium with medium, large with large. So I always start with a small one. So on the bigger triangle, on SIT, triangle SIT, my small side is 9. So I go and I look over here, and my small side, okay, is 6. So I know the 6 and the 9, those match up. Now I'm going to do the medium sides. So I see I have on triangle SIT, I have 12 and 15. So 12 is the smaller of those. Okay, so that's the medium one. And I look over here. Okay, my medium one is going to be 8. And if you notice, I'm putting the same shape around the sides that match on each triangle. And so now the 15 would match up with the 10 over there. So you can use your sides to match. You can use your angles to match. It just depends upon what they give you. So now we're going to fill in this little chart here. Angle D. Okay, what does angle D correspond with on our other one? Angle S. And you can see that in the name. Do you see how S and D are both the first letters in the name? All right, angle O. What is angle O going to match with? Angle I. And you can see that they're both 107 degrees. So angle O matches with angle I. And again, they're both the second letters in each of the names. G is going to correspond with T. You can use the names, you can use the pictures, whatever they give you. You can also do the sides too. DO. Well, DO is 8. That's our medium side, right? So go over here. What's our medium side over here? 12. And so what two letters does it go between? SI. Okay. IT. Well, let's use our names. IT. What does that match with? OG. And you can look there, look, IT, that's the side that I have the circle around the number. Look at OG, I have a circle around that side number. So those match. And then ST is gonna match with DG. And then lastly, they said, suppose that angle S is 25 degrees, what is the measure of angle D? Well, D corresponds with S, so they're going to be exactly the same size. So it's gonna be 25 degrees. So on similar figures, your angles are going to be the same size, but your sides will be different, okay? So on similar figures, the angles are the same, but the sides are going to be different. Okay, now we're going to determine if these triangles are in fact similar figures. Okay, and in order to do that, you're going to look at their sides. Okay, if all their sides are proportionate, then they're going to be similar. So first thing I'm going to do is I'm going to go over here and I'm going to match small with small, medium with medium, large with large. You always want to match up your sides first. So on triangle SIT here, my smallest side is 9. So go over here, and on this one, my smallest side is 6. My medium side on the big one is 10. My medium side on this smaller one is 8. My larger side on the big one is 15. And then match with the largest side on the smaller one, which is 10. And so now we're going to look at all three ratios, and we're going to see if they are equivalent. So I'm going to do big over small. Okay, and I'm going to take a measurement from the big triangle, and I'm going to put it over its corresponding measurement from the small one. So I'm going to take 9, and I'm going to put it over 6. Okay, and you can turn these all into decimals. So 9 over 6, that's 1.5. Now we have to check our other two pairs, our other two pairs of sides. So again, we're taking the big measurement and putting it over the small measurement. So now I'm going to take the medium sides from each. So I'm going to do 10 over 8. So do 10 divided by 8, and it's 1.25. Now I'm going to do the last pair of sides. I'm going to do 15 over 10. And so 15 over 10 is 1.5. Now, you notice how we got 2 of them to be 1.5, but this other one here, 1.25, that's the odd one out. Since all 3 pairs of sides do not have the same ratio, these 2 triangles are not similar figures. Okay, since all 3 pairs of sides are not in the same ratio, they are not similar. And it's because of this guy right here. And then here, when I know I said big over small, you can choose to either do big over small or small over big. You just have to do the same, you have to write the same ratio for each time. You can't do big over small for one of them and then flip it and do small over big for another. And if you're going to go with big over small, you got to do it for all 3 pairs. Okay, now let's go over here. Again, I'm just going to do big over small again. Okay, and I notice here I really only have to do 2 ratios because I see on each triangle I have 2 sides that are the same length. So I only have to compare 2 pairs of sides. So I've got the 6 matches with the 3, and then the 6.5 matches with the 3.25. So again, I'm going to do a big measurement over a small measurement. So 6 over 3. Okay, and 6 divided by 3 is going to be 2. And now I will do 6.5 over 3.25. So 6.5 divided by 3.25, and that also gives me 2. So now you see how I got the same number out of both of my ratios, and technically all 3. That means that these 2 triangles are in fact similar because all the sides are proportionate, okay? So you need, for similar shapes, and it can be any shape, you need equal ratios for all the sides. Okay, so now since these are both the same, I know that these triangles are similar, and I'm going to write a similarity statement. So I'm going to do the first one here. Remember, you can name the first one however you want. So I'm going to go triangle ACB. So triangle ACB is similar to triangle, and now we're going to do the same pattern over here. We'll go FED. Okay. So very good. All right, a couple more here. It says find the missing side and complete the proportion. Okay, these 2 triangles, we're going to assume that they are similar since they're asking us to complete the proportions here. You're just matching the letters. So BC over YZ, okay, that would be equivalent to, let's see, BC is from the small triangle, so we could do BA, right? Over, and then what's the matching side over here on the bigger triangle? YX. All right, you could also have another ratio. We could do from the small triangle AC, right, over XZ. So just anytime they're asking you to complete the proportions, you're finding like another pair of matching sides. So like BA matches with YX, right? Okay, and AC matches with XZ. So that's why I matched those up. Now we're going to find the missing side, and we're going to do that by using our proportion. Okay, here we've got like a question mark, but remember that's just like X. Okay, it's like X we're going to solve there. So 4 comes from the small triangle, the 8 comes from the big one, and you can see we have the small triangle over the big triangle. And now we're gonna match here. We need to find yx here. This is our missing side. Well, what does it match with? The 3, okay? And the 4 goes with that 8. So we did small over big, and then the 3 comes from the small one, so, and our question mark comes from the big one. Just cross multiply, okay? 4 times x, that's 4x, equals to 24, because that's 8 times 3, divide by 4. So x is going to be 6. So our missing side is 6. All right, now for this one, we're going to, and I believe this is our last one, yay. We're going to solve for x, and we're going to find the scale factor. So first thing here, and we're going to, again, assume that these are similar because they're having us find this one here. So we're doing small over big, okay, small over big. So now we're going to find x first, and then we'll find that scale factor. So to find x, we're going to set up a proportion. So I can see this 1.2 is going to match with x, and the 4.6 is going to match with 6.9. And they want us to do small over big. That's just a suggestion. You don't have to go with that, but that's how I'm going to solve it. So 1.2 over its matching, which is x, is equal to, and now we have 4.6 over 6.9. And so then we will cross multiply. So get 4.6x is equal to, and just do 1.2 times 6.9, and we get 8.28. Don't leave off any decimals, okay? Keep all your decimals. And now divide by 4.6. Okay, so 8.28 divided by 4.6. So we get x is 1.8. Okay, x is 1.8. And now for that scale factor. Okay, for the scale factor here, we're going from the small one to the big one. Okay, from small to big. Small to big, and they will specify. Okay, they'll tell you which way you're going to go. So if you're going from the small to the big, remember with dilations, wherever you're coming from, that is the old one. Wherever you're going to, that is the new one. So you do new divided by old. Okay, new divided by old. And so our new one, I'm going to take a measurement that they gave us. Our new one is 6.9. Our old one was 4.6. And so just divide that, 6.9 divided by 4.6, and you get 1.5. And so that would be your scale factor. All right, that's all there is to it, guys, and I will see you in the next one.